everyone, welcome to Math Quiz. In this video, I am going to explain how to calculate Karl Pearson's coefficient of correlation using actual mean method. You know already it is one of the most widely used to measure to calculate coefficient of correlation. It is defined as R is equal to covariance between x and y over product of the standard deviations of x and y. That is, here R is a numerical measure which is used to measure the linear relationship between the two variables x and y, and also defined as the covariance between the two variables x and y to the product of the standard deviations of x and y. By just substituting the formula for covariance between x and y, we have 1 over n sigma x minus x bar y minus y bar. This is a formula which is used to calculate the covariance over, you know, the standard deviation of x is under root 1 over n sigma x minus x bar the whole square, and for sigma y under root 1 over n sigma y minus y bar the whole square. Just cancelling n in both numerator and denominator, we have a simplified formula. And this is the formula we have to use to calculate Karl Pearson's coefficient of correlation using actual mean method. And this formula is used only when the values of x bar and y bar are in whole numbers. That is, as a whole number, like x bar takes a value something like 12, 15, 50, or y bar takes a value something like 30, 25, 32, something like that. So as a whole number, if x bar and y bar has to take the values of whole numbers like 12, 15, 50, or y bar takes the value of 30, 25, 32, something like this, we make use of this formula. Also, the values of x bar and y bar seems to be too small. In such cases, we make use of Karl Pearson's coefficient of correlation using actual mean method is used. So, if x bar and y bar are small non-fractional numbers, then we have sigma x minus x bar y minus y bar over under root sigma x minus x bar the whole square sigma y minus y bar the whole square. This is the formula we have used to calculate Karl Pearson's coefficient of correlation using actual mean method. So, the values of x bar and y bar are whole numbers, and also the values of x and y are small. In such cases, we make use of the formula R is equal to sigma x minus x bar y minus y bar over under root sigma x minus x bar the whole square sigma y minus y bar the whole square. You just simplifying this, we get R is equal to sigma x minus x bar y minus y bar as written as sigma xy. This is sigma xy over under root sigma x square sigma y square. Here your x is x minus y x bar and y is y minus y bar. Here we have to take the deviations of the values x and y from their arithmetic mean, that is from their actual mean. That's why we have to mention, I have to mention here when deviations are taken from actual mean. That is nothing but our actual mean method. So, make use of this formula, we now calculate coefficient of correlation between x and y. Calculate Karl Pearson's coefficient of correlation for the given two variables x and y. The variables x and y takes the values, x takes the values 6, 2, 10, 4, 8, and the corresponding values of y are 9, 11, 5, 8 and 7. Now, I am going to first write down the formula for calculating Karl Pearson coefficient correlation. Here the values of x and y seems to be very small in numbers, so I have to prefer actual mean method. So, the coefficient of correlation is given by R is equal to sigma x minus x sigma xy over under root sigma x square sigma y square. Here x is nothing but x minus x bar, and your y is y minus y bar. For this, to have to calculate the values of r, first let me construct a table, whereas the first column consists of the values of x and the third column consists of the values of y. As I mentioned earlier, x is nothing but x minus x bar and y is y minus y bar. Now we calculate xy, x square and y square. For that, first we calculate the values of x bar and y bar first. So let me first add the values of x. 6 plus 2, 8, plus 10, 18, plus 4, 22, plus 8, 30. So sigma x is 30. And sigma y, that is sum of all values of y, 9 plus 11, 20, plus 5, 25, plus 8, 33, plus 7, 40. That is sigma y is equal to 40. So you know already the formula for calculating the arithmetic mean is x bar is equal to sigma x, that is 30 over number of observation. Here we have 1, 2, 3, 4, 5. So totally we have 5 observations. So 30 by 5, you have 6. The value of x bar is 6. And next, y bar. Y bar is equal to sigma y, that is 40. Over here number of observation also 5. So 40 by 5, 8, which implies y bar is equal to 8. So now we calculate the values of x bar and y bar. Now we calculate its deviation of the values from x bar and y bar first and make it square. That is, first we calculate x minus x bar and x minus x bar the whole square. Likewise, for y to we calculate first y minus y bar and its square, that is y minus y bar the whole square. This is x minus x bar is x, that is x. So this is your x square, and this is y minus y bar is y, and this is your y square. And you make a product of these two, that is we need the xy value 2 in the numerator of the formula. Xy is nothing but xy, that is a product of x minus x bar and y minus y bar. First let me calculate x minus x bar, that is x minus x bar value is, x bar value we have calculated as 6. So x minus 6, that is 6 minus 6, 0, 2 minus 6, minus 4, 10 minus 6, plus 4, 4 minus 6, minus 2, 8 minus 6, plus 2. Now, let me calculate x minus x bar the whole square, that is square of this values. 0 square, 0. 4 minus 4 square is 16, plus 4 square 16, minus 2 square 4, and 2 square 4. We need this value, isn't it? That is sigma x square. You just calculate the sum of the values. Sigma x square is equal to 16 plus 16, 32, plus 4, 36, plus 4, 40. Now, let me calculate y minus y bar, that is y minus y bar value we have calculated as 8. So, y minus 8, and we calculate y minus 8 whole square, that is y square. So, 9 minus 8 plus 1, 11 minus 8, 3, 5 minus 8, minus 3, 8 minus 8, 0, 7 minus 8, minus 1. And we need the value of sigma y square. So by squaring these values we get 1 square 1, 3 square is 9, minus 3 square plus 9, 0 square 0, minus 1 square plus 1. So by adding all these values we get sigma y square is equal to 1 plus 19 plus 9 19 plus 1 20. Now xy, that is product of x minus x bar and y minus y bar, that is 0 multiplied by 1 we get 0. Next minus 4 multiplied by 3 minus 12, 4 multiplied by minus 3 minus 12, 2 multiplied by 0 0, 2 multiplied by minus 1 minus 2. By adding all these values we get sigma xy, that is equal to minus 12 that is minus 24, minus 2 minus 26, that is negative 26. We get sigma xy value. Now we have all the values for sigma x square, sigma y square and sigma xy. Now let me substitute in the formula. R is equal to sigma xy, that is sigma xy is minus 26 over under root sigma x square is 40 and sigma y square is 20, that is minus 26 over under root 40 multiplied by 20 we get 800. By taking the square root of 800 first, we get square root of 800 as 28.28427. We have to take up to 4 decimal places. So, 28.2843. And by dividing 26 by 28.2843, we get 26 divided by 28.2843, we have 0.919. We have to take up to 3 decimal places. So 0.919 minus 0.919. This is the value of R. So the coefficient of correlation between the two variables x and y is R is equal to minus 0.919. Based on this value, our interpretation about the coefficient of correlation between the two variables is there exists high negative correlation between the two variables. So R is equal to minus 0.919. That means there exists a high negative correlation between the two variables. Let me show you the scatter diagram of the relationship between the two variables here. So R is equal to minus 0.919. So there is a high degree of negative correlation between the two variables x and y. So let me show you the graph of this scatter diagram of this variables x and y. So look at here, there is a downward movement, which means there is a high degree of negative correlation, isn't it? Because all the points here cluster around the straight line, that is very small deviation of the points from the line. So there exists a high degree of negative correlation between the two variables x and y. Hope you got a clear idea about how to calculate Karl Pearson's coefficient of correlation using actual mean method. Thanks for watching. See you again in my next video.